Hey, Chan Physics, Mr. Block doing the combination circuits with the table. So this is that sheet that says combination circuit with tables. I'm going to skip right to here. This stuff, you guys, that we've been doing both the previous unit when we did electricity, and again we've done these now. So look at the key if you're still working on that. But let's go to this problem right here. And in my class, what we always do is we say we always try to come up with things that we can do over and over again, repeat. And so whenever we do a combination circuit, we do 3 steps. Okay, first we find the equivalent resistance, we redraw the circuit, and then if we can get to the 3rd step, we write down Ohm's law, V equals I times R, and solve for the current. And so we're going to do that here, but we're going to have to do that twice to get that done. So first thing I'm going to do is I'm going to say almost always in a combination circuit, you should always go as far away from the battery as you can and move towards the battery. Or otherwise you probably think, oh, these are in parallel with these, and you try to do something. And it's a lot easier to go over here and say, okay, wait a second. In this little branch right here, both these resistors get the same current. And if they're getting the same amount of current, then they have to be in series. And so we can do step 1, which is step 1 is we say, okay, we're going to combine these 2 right here. And so in my thing, it looks like this. And then we write down RS for our series equals 1 plus 1 or equals 2. Okay, so now we have combined these 2 and we can redraw. So step 2 is redraw. So we have a 9-volt battery that we didn't touch. We have a 2 ohm resistor that we haven't done anything to. And now we have taken these other 2 and put them together into 1, and it's a 2 ohm resistor. So this 2 right here, 2. And so now we look at this and we go, this is clearly 2 resistors in parallel. So I'm going to combine those with the parallel. So 1 over Rp is equal to 1 over 2 plus 1 over 2. 1 over Rp is equal to 2 over 2. And so now even if we flip these, right, Rp over 1 is still going to be 2 over 2 or 1. Okay, so the total resistance of the circuit is 1. And if I would then go to up here and I'll say, okay, well now I can go to step 2, because this is step 1. Find the total resistance, redraw. Find the total resistance, redraw. So now we're going to go 9 volts. And we have a 1 ohm resistor. Okay, so we redraw. That's step 2. And now we have the easiest circuit we can. So now we can go ahead and do step 3, which is write down Ohm's law, V equals I times R, or 9 equals I times 1. So we get I is equal to 9. All right, so now what we do in my class is we say, okay, now we've worked down, now we work back up before we start going into this right here. So how do we go back up? Well, all we're going to do is tell ourselves that the 9-volt battery is pushing out 9 amps. Okay, so 9 amps are coming out of the battery. And since this is an equivalent circuit to this, then this battery has to be pushing out 9 amps. And this battery has to be pushing out 9 amps. So you see we work down, and now we work back up. And so now we're ready to go ahead and look at what we can do here. And so this one is really one of the more difficult combination circuits, because when we look at this 9 volts, 9 amps coming here, we immediately get to a branch here. And we know that the current has to split between this branch and this branch. We just don't know how much they're going to do it. So there's actually 2 ways to look at that. The first way is the one that we've been teaching, and that is the voltage rule. And that is, if we are a little electron, because that's what electricity is, a little electron is running around here. If this little electron comes to the back of this battery, it's dead tired, no energy at all. And the electron gives it 9 volts, the battery gives it 9 volts, so now it's ready to go. And so by the time it gets to here and decides to go down this way, we get to the back of the battery again. So it has to lose all 9 volts through this 2 ohm resistor. That's Kirchhoff's law, right? We gain 9, we have to lose 9 before we get to the back of the battery. So in our 2 ohm resistor, the voltage drop has to be 9. Okay? So once we get that, we can say, well, now I see that Ohm's law, V equals I times R, is really right here in the RIP table right here, right? V equals I times R. So to find I, we just take 9 divided by 2, and we get 4.5. All right, so that's great. We got this one, but how do we do this one? And so now we have to say to ourselves, okay, well, let's draw that in there. Here's 4.5 down here, right? 4.5 amps go here. And so if 9 comes into this little nodule and 4.5 goes down, that leaves 4.5 to go this way, right? So 4.5 amps has to go through this one and this one. And so we can write down 4.5 and 4.5, right? Because it's going through both of those 1 ohm. And now we can say, oh, wait a second. R times I is V, so 1 times 4.5 is 4.5, and 1 times 4.5 is 4.5, okay? And now the only thing left is, what are we going to do in the totals? So our total right here is 1. Our total I is 9. And to be honest with you, I don't think that there's any meaning to this box for parallel. It does have some meaning for series, but that box right here. The truth is, how are we going to check to make sure we got it right? Because in the past, we could add up the voltages in a series circuit, and they should add up to the battery. And we could add up the currents in a parallel circuit, and it should add up to the current coming out of the battery. So how do we test in a combination that we did it right? And the best way is just to pretend like you're a little electron and go around both loops. So if we gain 9 volts here, we lose 9 volts here. We did that. Right? Now we're a different little electron. We get here, we're dead tired. We gain 9 volts, and we're going to go around the outside like this. And so if we gain 9 volts, we lose 4.5 here, right? And we lose 4.5 here. We're back down to 0. So these two add up to 9, and they are that second branch right there. And we're confident that we did that problem correctly. Okay? All right, 7 minutes. We got to go a little faster. I'm going to skip the middle one, and I'm going to go to the last one because it is the hardest one. And I'm going to make sure you guys can see what we're doing here. Okay, so what we got here is all this stuff here. We look at the battery. We say we got to go as far away from the battery as we can. So up here in this corner, and we see that there's 250 ohm resistors. They are in series, right? Because they get the same kind of current. And so we can start by adding those two together. And so we're going to go RS, this is step 1, is equal to 50 plus 50, or is equal to 100. All right, I'm going to redraw real quick. We didn't touch this resistor. We came to the branch here. We added these two together into one. We didn't touch this resistor. And so now we have a resistor here. So we have a 50 here, a 50 here, a 300 here, and a 100 there. Okay, so that's our step 1. So now we're going to get a little bit easier. So now we look at this redrawn, and we see, well, these two are definitely in parallel. So I'm going to do step 1 again. This time they're in parallel, so 1 over Rp is equal to 1 over 300 plus 1 over 100. All right, so 1 over Rp is equal to 1 over 300 plus 3 over 100. So 1 over Rp is equal to 4 over 300. All right, so we just common denominator, add 1 and 3, we get 4. Now we flip them, right? Rp is equal to 300 divided by 4, or 75. So these 3 right here, or these 2 right here, are equivalent of 75. All right, so that's step 1. Now we have to redraw. So we'll redraw one last time. And we didn't touch this 50. We now have all 3 as a 75, and we still have this 50 right here. So we have a 50 here, a 75 here, and a 50 here. Okay, so step 1, step 2, step 1, step 2. All right, step 1 again, RS, these are all in series, is going to be 50 plus 75 plus 50, or 175. All right, we can redraw again. We get a simple circuit. Okay, so sorry, we had to go back a little bit, so it might be a little bit janky there, but this is a 700 volt battery right here, and a 175 ohm resistor right here. And so when we write down V equals I times R, we have 700 equals I times 175, and that's 4. Okay, and so now we're at 4. And so if the once we've figured out that the current is 4, we can go backwards. The battery's pushing out 4. This battery's the same as pushing out 4. This battery's the same as pushing out 4. This battery's pushing out 4. So there's 4 amps coming out right here. Well, how does that help us? Well, we know that the current here has got to be 4. And then after it goes through this, this set of all these, it's got to come back to 4, right? Because it's going to go through the battery. So we know the current here is 4 and the current here is 4. So we can put them in here. And then we can multiply across 50 times 4 is 200, and 50 times 4 is 200. How does that help us? Well, we know that we have to gain 700, and we have to lose all 700 throughout this, right? So now we're going to go to voltages. If we've lost 200 here, and we've lost 200 here, then we have to lose 300 between this point and this point. Well, that's pretty good, because right here, right, we have this 300 ohm resistor, and so we know we're going to lose 300 volts there. Well, now we can look, V equals I times R, or 300 divided by 300 is 1, right? And that tells us that the current here is 1. So if the current coming into this point was 4, then the current one is going through here is 1. So the current up here has to be 3. All right, that's these two resistors right here. That's these two right here. So I can put a 3 here and a 3 here. And now we've got 50 times 3 is 150. And 50 times 3 is 150. Right? And the only thing left now is to make sure that we did it right. And the way we do it right, make sure we did it right, is we say, okay, we gain 700 no matter what path we take, we have to lose. So if I go through here, I gain 700, I'm going to lose 2. I'm going to come up here, I'm going to go through here, I'm going to lose 300, and then I'm going to lose 200. So 200 plus 300 plus 200 is 700. So certainly this inside loop, I gain 7 and lose 7. Right? What about the outside loop right through here? So I go through here, I lose 200, I come up here, I lose 150, I lose another 150, and I lose 200. So 200 plus 150 plus 150 plus 200 is also 700. And so we're right. And you can see right here, right, that these two combine to give us the 300. Right? Again, no real meaning to this right here. The total current coming out of the battery is 400. The total resistance is 175. But anyway, that's it. So like I said, it's one of those things where we have to do the work, go backwards through, and then start looking, what do we know, and start picking off pieces one by one to fill in the blanks. Right? If you got any questions, definitely come see me. Be working as hard as I can for you guys this week and next week. So please don't let anything go too long. Just come over and talk to me. Talk to you later. Bye-bye.